Hello everyone, today we are going to solve the higher level paper 1A, which was conducted on 16th May 2025 in Indian subcontinent. Now, as per the new syllabus, this was the first paper, and the paper 1 is divided into two parts, paper 1A and paper 1B, and it was total for 2 hours. That is, you have to complete 1A and 1B in 2 hours. You can divide it as 1 hour for paper 1A and 1 hour for paper 1B. It was your choice. Now, I hope we had completed this paper 1A in about 40 to 45 minutes, and the remaining paper 1B in next 1 hour. The total marks were of 75. This was the first paper of the new course held in 2025 May. Okay. The first question of this is, the diagram below shows the behavior of protons, neutrons and electrons in electric field. And as we can see, there is electrodes, positive and negative electrodes are there in a beam of particles. They are allowed to pass through these electrodes. It is found that the X is bending towards positive electrode, Z is bending towards the negative electrode, and Y is moving without any deviation. Since X is bending towards the positive electrode, it means X should be a negatively charged particle. Z towards negative electrode, it should be a positively charged particle, and not deflecting, it should be a neutral particle. When it is neutral, it should be a neutron. When it is negatively charged, it should be an electron, and when positive charge, it should be a proton. So we can find out X is my electron, X is electron, proton is Z, Z is proton, X is electron, and Y is neutron. So this is the option correct. Answer is C. Okay. The next question is question 2, and in this question it is saying, which of the following species have same number of outer electrons? Letters do not represent the symbol of elements. Okay. Z, 9 electrons are there, 1 added, it means 10 electron. Configuration is 1s2, 2s2, 2p6. Okay. Y, now 1 electron is removed, 2 electrons are removed, it means 19 electron. Configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. This should be the configuration of Y2 plus. X minus, it will 16 and 1 added 17 electrons. Configuration will be 1s2, 2s2, 2p6, 3s2, 3p5. Now next is W2 plus, that is out of 12, 10 electrons are left behind. There are 10 electrons, there are 17 electrons, there are 19 electrons, and there are 10 electrons. So that should also have 1s2, 2s2 and 2p6 configuration. Thus it will have 8 electron the outermost shell, it will have 7 electron the outermost shell, this will have 1 electron the outermost shell, and this again have 8 electron the outermost shell. So my answer will be Z minus and W2 plus. Z and W, that should be the answer. Answer is D. Okay. Now the next question is question 3, which says which chart shows the neutralization curve of a strong base with a strong acid. Strong base titrated with a strong acid. What we are doing, we are adding a strong acid to a strong base, and since the base is strong, the graph or the pH curve should start around 14, and since the acid is weak, should it go around 1. So we have to look for the graph is starting around 14. It's starting around 14 but not going till 1. It means it is not possible. Starting from 0, not possible. Starting from around 14 and going till 0, it means answer could be C. But we look for the D also. In D, starting from around 3, not possible. That means the pH curve will be C, starting from 14 and ending around 1. Next question 4, which diagram shows the correct electronic configuration of nitrogen atoms in the ground state. Nitrogen atom in ground state, atomic number of nitrogen is 7. Configuration is 1s2, 2s2 and 2p3. It means there should be 1s and 2s, they should be completely filled, and the p orbital, p subshell of the second shell should be partially filled. And as per Hund's rule, all of these p orbitals should have 1 electron each. 1s is completely filled, 2s is completely filled, and all the p orbitals having 1 electron each. Therefore, as per Hund's rule, this should be the correct answer. Answer should be A. If I see B, there is no electron in this, wrong. There are 2 to 4 and 5 electron, configuration wrong. This is also configuration wrong. So answer is A. Next question is, which row shows a gas that would deviate the least from the ideal gas behavior? Least deviation I require. Now, for the gas to deviate least, it should have poor attraction forces and should be less compressible. Poor attraction forces should be there. we have phosphine as an example and ammonia is the second option. And when we talk about ideal gas behavior, ideal gases behave like ideal at low pressure and high temperature. Temperature should be high and pressure should be low, therefore it will be near ideal, or we can say least deviation from ideal gas behavior. So we have to look for low pressure and high temperature. Low pressure and high temperature, these two should be the option. Rest are wrong. Now out of these two, one is phosphine, other is ammonia, and we know in ammonia there are hydrogen bonding. Ammonia has an extra bonding with hydrogen bond, due to which it will have higher attraction, more deviation in case of ammonia. Higher attraction forces, more deviation. Phosphine does not have any hydrogen bond, although it has intermolecular forces, but hydrogen bond is absent in phosphine, hence it will have less deviation from ideal gas behavior. Poor attraction forces, less deviation, hence answer should be A. Okay. Next, question 6, which is which of the following correctly shows the shape of S and P orbital? We know S orbitals are spherical in shape because they have equal distribution, or electron density around them is same in all directions, whereas P orbitals, they are directional in nature and they are dumbbell shape. We look for spherical shape and dumbbell shape. Spherical and dumbbell, again wrong. S and P both are dumbbell, wrong. S is spherical and P is dumbbell, correct. Answer is D. Okay. For sixth, answer is D. Seventh question says, which rows shows the correct formula and electron configuration of the species in calcium nitride? Correct formula and electron configuration of the species in calcium nitride. Now calcium nitride is Ca3N2. That is calcium nitride, Ca3N2. Out of this Ca3N2 is A is wrong, B is wrong. It could be C and D. Now electronic configuration of calcium. Calcium has Ca2 plus charge and its electronic configuration is, atomic number is 1s2, 2s2, 2p6. Atomic number is 20, out of that 2 electrons go on 18. 1s2, 2s2, 2p6, 3s2, 3p6, which is equivalent to argon. I can say it is Ar. Species should be Ar. Calcium should have Ar. Now this Ar is matching. What about nitrogen? Nitride N3 minus is the species. Nitrogen has 7 electron, 3 added. It will have 1s2, 2s2, 2p6, which is equal to neon. Therefore, the correct answer is neon and argon. Argon for calcium, neon for nitrogen. Answer is D. Okay. Next question is question number 8. The diagram of the 4 stable allotropes of carbon are shown below. Which row correctly identifies each structure? Okay, so as we know, this is a direct question from the course of chemical bonding, allotropes of carbon, and this structure in which each carbon atom is connected to W structure, each carbon is connected to 4 other carbon atoms, it is of diamond. And this is graphite, hexagonal structure, and this is fullerenes, buckyball like structures, and this is graphene, a single layer of graphite. It means Z is graphene, Z graphene, Y fullerene, X graphite, and W diamond. Answer A is correct. Since graphene is Z and this is the only option in which graphene is Z, hence the answer is A. For 8th question, answer is A. In which of the following molecules do all atoms obey the octet rule? All atoms obey octet rule. Octet rule means 8 electrons in the outermost shell. Now in NF3, nitrogen has 5 electrons and it is bonded with 3 fluorine atoms. Shared 3 electrons with 3 fluorine atoms, total 8 electrons in nitrogen. It obeys the octet rule. Yes. BF3 is an electron deficient compound. It has only 6 electrons in the outermost shell, hence it do not obey the octet rule. PCl3, again phosphorus has 5 electron outermost shell and it is bonded to 3 chlorine atoms, forming 3 covalent bond, total 8 electron outermost shell, hence it also follows the octet rule. It means answer is 1 and 3, which obeys the octet rule. 1 and 3 only. 1 and 3 only is B. Answer B. 9th question is answer B. Question 10 says nitrogen 1 oxide N2O is represented by 2 Lewis formulas. These are the structure X and structure Y, 2 formula. Which row correctly identifies the formal charges and the more stable structures? Okay, so we have to find out the formal charge and the more stable structure. For finding the formal charge, I am numbering this as 1, 2, 3 for the structure, 1, 2, 3 for the structure. For structure X, if I want to find out the formal charge on atom number 1, which is nitrogen, What's the formula for formal charge? The formula for formal charge equals to valence electron on the atom minus lone pair electrons minus bond pair electrons divided by 2. This is the formula. If I want to find out the formal charge on atom number 1, which is nitrogen atom number 1 of X atom 1 is nitrogen. Formal charge on nitrogen of the first structure is valence electron in nitrogen is 5 minus lone pair electron in this atom is 2, lone pair electron is 2 minus bond pairs. It is forming 3 bonds. It means 6 electrons divided by 2. 5 minus 2 minus 3, it equals to 0. Okay, the formal charge on the structure number 1, structure 1, which is X nitrogen atom, is 0. It means my answer could be A or C, in which nitrogen atom has a 0 formal charge. Okay, we'll move to next part. Second nitrogen atom, and how many is atom number 2? This was atom number 1. Valence electron again 5, minus lone pairs, there is no lone pair, 0, minus bond pairs, it has found 4 bonds, 3 with other nitrogen and 1 with oxygen, 4 bonds total, 4 means 8 electrons. 8 divided by 2 equals to 4. 5 minus 4 is plus 1. Second atom has a charge of plus 1. Second has a charge of plus 1. It means plus 1 for both. Answer could be A and C both, because both have a charge of plus 1. Now we will have to move to the next. Next is oxygen, atom number 3. Atom number 3 is my oxygen. Oxygen valence electrons are 6 minus lone pairs. It has 6 lone pairs, 6 lone pair electrons, 6 and 1 bond pair electron, 2 upon 2. That is 6 minus 6, 0 minus 1. Answer is minus 1. Now the third atom has minus 1. It is again same. Thus we have to find out the formal charge of structure Y also. We will find out the formal charge on structure Y. Now for Y structure, atom number 1, formal charge on atom number 1, which is N. First atom is nitrogen. The formal charge is 5 minus, it has 4 lone pair electrons minus 4 bond pair electrons, 4 upon 2. 5 minus 4 minus 2. 5 minus 6, is minus 1. The charge on the first is minus 1. If I go on this, charge on first is minus 1, again same. Now we'll move to the next nitrogen, atom number 2, nitrogen again. Number of electrons, valence electron 5, lone pair, there is no lone pair, and there are 4 bonds, that is 8 bond pairs, 8 upon 2, that comes out to be plus 1. Second nitrogen has a charge of plus 1, and the second nitrogen has a charge of plus 1, which is A, not this, it will not be answer C. My answer will be A, but I have to find out more stable. I will find out the formal charge of oxygen also in this case. Oxygen is there's 6 bond valence electrons minus 4 lone pairs minus 4 bond pair electrons, that comes out to be 6 minus 4 minus 2, that is equals to 0. Now I can see there are no, in both of these molecules, all atoms formal charge not equal to 0. Thus we have to look for the molecule in which the atom which is more electronegative has a negative formal charge. More electronegative element has a negative formal charge is in molecule X, not in molecule Y. Hence my molecule X is stable. Therefore finally 100% my answer is A. Question 11 says, which rows put these molecules in order of decreasing bond angles? Decreasing bond angles. There are 4 different types of molecules. One is ammonia, bond angle is 107, H2O bond angle 104.5, C2H4 bond angle 120 degree, and CH4 bond angle 109.5 degree. Now we have to arrange them in decreasing order. So first I have to put the molecule having highest bond order, which is C2H4. C2H4 bond angle 120, then CH4 109.5, then ammonia 107, and then water. Answer is C. Okay, so this is decreasing order of bond angle. Next question is question 12. The following thin layer chromatogram was obtained from a mixture of naphthalene C10H8 and naphthol C10H8O. C10H8 and C10H8O. The polar silica was used as a stationary phase and a non-polar hexane as the mobile phase. Okay, polar silica was used as a stationary phase. Okay, got it. So naphthalene and naphthol. Naphthol has OH and this OH will have hydrogen bond. This we should know here. The OH should have hydrogen bond. If I see this chromatogram, I see the marking is done from 0, then 1, this is 2, this is 3, then 4, then 5, then 6, and then 7. Okay. Now there are 2 components, one is X, other is Y. What are the positions and the retardation factor of naphthalene? Now, if I see this structure, naphthalene has a non-polar structure without any hydrogen bond, whereas naphthol has a hydrogen bonded structure. Naphthalene, since it is non-polar and will absence of hydrogen atom, absence of hydrogen bond, no hydrogen bond could be formed, hence it will have more adsorption on the chromatographic paper. Adsorption, that is, it will move to a higher part, goes to higher part on this chromatogram. X will go to higher part in the chromatogram, and difference of this is taken from the baseline. Baseline is 1. 5 minus 1 equals to 4. This is the distance traveled by X. So the RF factor for X is distance traveled by the component upon distance traveled by the solvent phase. Now the solvent front goes to 5. That is 6 minus 1 equals to 5. Solvent front goes to 5 centimeter. The component X goes 4. RF factor will be 4 divided by 5. That is equals to 0.8 for X. For the position retardation factor of naphthalene, the naphthalene will be at position number X and retardation factor is 0.8. X and 0.80. That's the answer. Answer is C. Okay. What I done is, naphthol will absorb less because naphthol is hydrogen bonding. It will get stuck to, it will get connected to the polar silica. There will be interaction between the polar silica and the hydrogen bond naphthol. It will not move more. That is, X will be your naphthalene and Y will be naphthol. And then we had finding out the retention factor. And thus we got the answer C. Okay. Next is Kekulé. Question 13 says Kekulé suggested a structure of benzene with alternating single and double bonds. Which piece of evidence disproves this structure? Which piece of evidence disproves this structure? Now, benzene is the formula C6H6. No. Benzene is an unsaturated molecule. No. All CC bond lengths are same due to resonance in benzene. Resonance in benzene, all the bond length they become equal. Bond order comes out to be 1.5. Thus the bond length become equal. Hence, the piece of evidence which disproves this structure is C, which shows that due to resonance, all the CC bonds are of same length. They have partial double bond characteristic. For question number 13, answer is C. Question 14. Germanium has several stable oxidation states. Which row shows these species in order of increasing radius? So as we know, whenever we form a cation, its size is always smaller than a neutral atom, and the anion is always larger than the neutral atom. So we have to look for the cations and anions. G plus 4, then plus 2, then neutral, then anion. This could be the answer. G minus 4, no, not possible. The increasing order we have to find out that this is the largest radius. G plus minus 4 is largest. Not possible. B. Germanium neutral, not possible. Germanium 2 plus, also not possible. Germanium plus 4 is highest radius. It's wrong. It has the lowest radius. The answer is A. If it says G plus 4, G2 plus, Ge and G4 minus, this has the lowest radius and this is the highest radius. Okay, this is the answer. 14th answer is A. Which statement explains the trend in the first NHNG from sodium to chlorine? Trends in the first NHNG from sodium to chlorine. As I move from sodium to chlorine, what is happening? The nuclear charge is increasing. Nuclear charge is increasing, yes, because the proton number is increasing, atom number increasing, and the shells remain same. Therefore, the nuclear charge increases, correct. Electronegativity decreases, no. Atomic radius increases, no. Shielding effect decreases, no. It goes on increasing. Therefore, the answer is A, which says that nuclear charge increases as we move from sodium to chlorine. Question 16, which elements would react with each other most vigorously? Most vigorously, which reacts, okay. As we move in alkali metals down the group from sodium till cesium, the reactivity goes on increasing. It means potassium will be more reactive than sodium. Okay, the answer could be A or B. Now, in case of halogens, if I move down the group from fluorine, chlorine, bromine, if I move down the group, the reactivity goes on decreasing. It means chlorine will be more reactive than bromine. Hence, potassium and chlorine, they will react more vigorously with each other. Answer is B. 16 question answer is B. Next question is 17th, which says that the volume of a container filled with a fixed amount of gas, amount is fixed, increases by 100%, okay, at a constant temperature, How does this affect the pressure of the container? Okay, increase in 100% means doubles. Now the formula is P1 V1 equals to P2 V2, because number of moles are same and gas constant is same, it will be cancelled out. I can say P1 V1 is equal to P2 V2. Or if I say P1 into X equals to P2 into 2X, or P2 equals to P1 into X upon 2X, that is P2 equals to 50%. P2 becomes 50% of the P1. Answer is it decreases by 50%. Therefore, the answer for P2 will be 50% of P, which is P1. 1 upon 2 of P, P2 equals to 1 upon 2 P1, which I can say 50% of P1. Hence, the answer is D for question number 17. Question 18. Which statement explains why transition elements have variable oxidation state? 18 is why transition elements have variable oxidation state. Now, transition elements have variable oxidation state, as you know, because the last and the penultimate shell electrons both can participate in the bond formation. Therefore, the answer should be around this. A option is D electrons are delocalized. All have plus 2 oxidation state. No, D electrons are delocalized. That is also not correct. They can accept electron pairs from ligands. Also not correct. Successive ionization energies are closer with each other. Due to this, the last and the penultimate shell electron participates, and the answer is D. For question 18, answer is D. 19th, which oxygen containing molecule has the low resolution HNMR spectrum? This HNMR spectrum has been given, and I have to see which of the molecule has this HNMR spectrum. Now, HNMR spectrum, as you can see, there are 4 lines, 1, 2, 3, 4. It means, as I observe this HNMR spectrum, I can say there should be 4 hydrogen atoms in different environment. 4 different environment of the hydrogen atoms. 4 different environment of hydrogen atoms. As we can see, there are 4 different spectral lines. Now, we have to go for this compound, and we have to find out which of the following molecule has 4 different hydrogen atoms. Environments. Butanoic acid. First is butanoic acid, which is CS3, CH2, CH2, COH. Second is ethyl ethanoate, which is CS3, CO, C2H5. That is, I can write in this way. It is also written in form of CS3, CH2. Okay. Next is methyl propanoate. CS3, CH2, CO, CH3, methyl propanoate, and butanone. CS3, C double bond O, CH2, CH3. As we can see, in molecule number 4, that is D, only 3 environments are present, not possible. In molecule number C, that is 2-methyl-propanoate, only 3 environments, this cannot be an answer. This also is only 3 environments of hydrogen. The simplest answer for this question is, since butanoic acid has 4 different environments, one for this proton, one for this proton, one for this, and one for this. 4 different protons in 4 different environments. Hence, the answer for this question is butanoic acid, because this can only form this spectrum or this 4 different spectral lines. Since since this molecule has 4 hydrogen atoms in 4 different environments, hence all the 4 spectral lines, they will be formed by butanoic acid only. Okay. Next, consider this molecule deca 357 triene 2,9 dione. How many stereoisomers are possible for this compound? Deca 357 triene 2,9 dione. Now I can see how many double bonds are there. 1, 2, 3. 3 double bonds, and this is a double bond of on, that is ketonic group. Now we know stereoisomers are formed by the carbon atoms having different orientation, and that can be around a double bond. That is, the number of double bonds will control the number of stereoisomers. Now there is a shortcut, or we can say there is a law which says that if odd number of double bond molecules are present, odd number of double bonded molecules are present, double bonds are present, we can say double bonds are present. If there are odd number of double bonds, then the formula to find out the number of stereoisomers is 2 to the power n. That is, n is the number of double bonds, 2 to the power 3, that is equals to 2 into 2 into 2, and that comes out to be 8. That should be the answer. Number of double bonds and 2 to the power n, where n is equal to number of double bonds, and that will give you the number of stereoisomers. Answer is 8. Okay, if it is odd number of molecules, odd number of double bond present in the molecule. Got it? Since there are 3 double bonds, which is an odd number, hence I written 2 to the power 3, and which is equals to 2 into 2 into 2, that is equals to 8. Answer will be 8. 21. What is the disadvantage of using infrared spectroscopy? It's a technique. Now, infrared spectroscopy, infrared tells us about the type of bonds, but it cannot identify their position. It cannot tell us about where they are present. It cannot detect small atom like hydrogen. It can only detect molar masses. It alters the chemical structure of the molecule sample. All these, it can only identify bonds, not their position. What's the disadvantage? It can only identify the bonds, not their position. This could be a disadvantage of infrared spectroscopy. Therefore, the answer is D. Next question is question 22, which says that which equation correctly shows both enthalpy of formation and enthalpy of combustion of the compound, enthalpy of formation of a compound and the enthalpy of combustion of its elements. Okay, enthalpy of formation of compound always takes place from elemental state of the elements of the compound, whereas enthalpy of combustion is whenever it is reacting with oxygen and forming the products. If I say, if the question option A, if I see option A is carbon monoxide, which is not an element, therefore it could be a combustion, but it cannot be enthalpy of formation. Nitrogen reacting with hydrogen, it could be formation, but it cannot be combustion. Sulfur reacting with oxygen to form SO3 gas, this can be a elemental state of sulfur and forming a compound SO3. It is combustion, but since it is from combustion as well as formation both, but since there are 2 moles are forming, it cannot also be the answer. Now next question is hydrogen, its elemental state is gas, oxygen elemental state is gas, water elemental state is the compound state is liquid, standard state is liquid. Hence the option D, it shows combustion of hydrogen as well as formation of water from its elements in their elemental state. Therefore the correct answer is D. Next question is question 22. It says that which equation correctly shows both enthalpy of formation, delta HF degree formation of a compound, and enthalpy of combustion of its element. We have to find out the equation which shows both enthalpy of formation as well as enthalpy of combustion of its elements. If I talk about A part, in this carbon monoxide reacts with oxygen, it is enthalpy of combustion but not of its element, and it's also not enthalpy of formation. Why? Because carbon monoxide is compound, not an element. So answer A is wrong. Half N2 plus 1.5 H2 gives you ammonia. This reaction shows the formation of ammonia. That is, enthalpy of formation is correct, but it is not enthalpy of combustion, because for combustion we require oxygen, it is not present. Sulfur burns with oxygen to form SO3, but since there are 2 moles of sulfur, and for finding out enthalpy of combustion we require per mole, hence this cannot be the option. The last is hydrogen gas, reacts with half of oxygen gas and form water, which is a liquid. Now this is enthalpy of formation of a substance in its element in its natural state or standard state. Water exists in form of H2O in its standard state, and it is formed from its element in the standard state, that is hydrogen and oxygen. Hence it is enthalpy of formation correct. It is also the enthalpy of combustion. Why? Because hydrogen is combusted in presence of oxygen to form water. Both of these answers are both of these equations, enthalpy of formation and enthalpy of combustion, are satisfied by option D. Hence the answer is D. Next question, question 23, which says that 0.050 mole of sodium hydrogen carbonate NaHCO3 was added to 50 centimeter cube of 2 mole per dm cube solution of citric acid. Okay, concentration and volume is given to us and moles are given to us. The initial temperature of solution was 298 Kelvin and the final temperature was 297. This shows that the reaction is endothermic. The temperature falls. What is the enthalpy of this reaction in kilojoule per mole? Given C, the specific heat is 4.18 and formula Q is equal to mc delta T. Okay, by finding the formula, by using this formula Q equals to mc delta T, I'll find out Q. What is the M? M is the amount of solution which absorbs the heat, and that is equals to volume, 50 centimeter cube, and then 50 centimeter cube we consider the density equals to 1. Therefore volume equals to mass, and that equals to 50 grams. I have Q equals to mc delta T. M is 50 grams into 4.18 into delta T. There's a fall in temperature and delta T is 1. I'll write 1. Q comes out to be 209 in joule divided by 1000. I will get 209 upon 1000, and that comes out to be in kilojoules. Okay. Now, in order to find the enthalpy of reaction, we require delta H equals to Q upon N, which is the number of moles of Lr. How to find out Lr for this reaction? Now we have moles of citric acid, and that's equals to C into V. C is what? C is 2 mole per dm cube into volume is 50 and divided by 1000. So that comes out to be 0.1 mole. Moles of NaCO3 already given to us, 0.05. Now in order to find out the Lr, we'll divide this NaCO3 by 3 because 3 moles reacts with 1 mole, and 0.01 by 1, so I'll get 0.1, and it will comes out to be 0.0167. So we can see NaCO3 is the smaller, hence NaCO3 is my Lr. Using the moles of NaCO3 0.05, I'll find out delta H. Now the delta H will be equals to Q, which is 209 divided by 1000 into 1 upon N, that is the Lr, which is 0.05. On calculating, I find it out that it is 4.18, and it is in plus. Why? Because the reaction is endothermic in nature. Answer will be 4.18 plus, which is the A part. Okay, this is question number 23. Question 24. The table shows enthalpy of combustion data for several substances. Number 1 is C2H6, C2H4 and hydrogen. The question is, which expression would give the enthalpy for the following reaction? C2H4 reacts with hydrogen to form C2H6. This is the reaction, and we require to find out the enthalpy of the reaction. The formula for enthalpy of reaction in terms of combustion is enthalpy of combustion of reactants minus summation enthalpy of combustion of products. What is the enthalpy of combustion of reactants? Reactants are C2H4 and hydrogen. Therefore, the enthalpy of combustion of reactant will be minus 1411 plus minus 286. That is enthalpy of combustion of reactants. Minus enthalpy of combustion of product. Product is C2H6 minus 1561. This will be the expression. Minus 1411 minus 1411 minus 286. No, A is not the answer. Minus 1411 minus 286 plus 1561. Yes, B can be the answer, but we'll look for C also. Minus 1411 plus 286. No. Minus 1561. No, it is plus 1561. It means A, C and D are wrong. Answer is B. Okay. Question number 25. Which of the following reaction will have the largest positive change in entropy? And we know entropy increases when the solid converts into gas, a molecule converts into atoms, or a compound converts into small molecules. If I see this reaction A, CaCO3 solid reacts with aqueous HCl and form CaCl2, H2O and CO2 gas. We can say the number of moles of gas is increasing. So this can be a positive change in entropy. CaO plus CO2 gas converts into CaCO3, no negative change, gas converting into solid. 2 moles of gas converting into 2 moles of gas, there is no change in entropy. 2 moles and 3 moles of gas converting into 2 moles of gas, decrease in entropy. This cannot be the answer. Hence, the largest change in entropy is coming out to be for option A, where CaCO3 solid is converting into CO2 gas, solid and aqueous solution converting into gas, number of moles of gas is increasing. 26, which says that chloroethane is produced by the reaction of ethane with chlorine. Okay, ethane C2H6 reacting with chlorine to form chloroethane and HCl. The molar masses is given. He's asking what is the atom economy for this reaction, and percentage atom economy formula is given to us. Atom economy of this reaction is the molar mass of the desired product upon molar mass of the reactants. What is the desired product? C2H5Cl. And what is the molar mass? 64.52. Therefore, atom economy will be 64.52 divided by molar mass of all the reactants. We have reactant C2H6, which is ethane. Its molar mass is 30.08 plus chlorine Cl2, which is 70.90. 30.08 plus 70.90. This is the molar mass of the reactants into 100. If I calculate it, I get 64.52 upon 100.98, and that comes out to be 63.9%. That will be the answer. Therefore, the atomic economy answer is 63.9%. For 26th, answer is C. Next question 27 says 75 centimeter cube of propane was completely combusted in 400 centimeter cube of oxygen according to this equation. And we see this is propane, which is gas, oxygen gas, CO2 gas, and water liquid. If I want to compare, I can compare these gases volume directly. I can say 1 volume of this propane reacts with 5 volume of oxygen and forms 3 volume of carbon dioxide gas. If I talk about gases only, what volume I have? I have 75 centimeter cube of propane and 400 centimeter cube of oxygen. What will be the LR? I'll have to find out the LR. 75 divided by 1 and 400 divided by 5. It comes out to be 75, and that comes out to be 400 divided by 5 is 80. What is LR? LR is the propane is my LR. Now, as per this, 1 volume of this propane reacts with 5 volume of oxygen and gives you 3 volume of CO2. 75, 1 volume reacts with 5 volume. 75 will react with how much? 75 will react with 75 into 5 divided by 1, that comes out to be 375 centimeter cube, which is the amount of oxygen required for the reaction. What will the remaining oxygen? Remaining oxygen is 25 centimeter cube. 375 minus 400 is 25. So I have 25 centimeter cube of oxygen. What is the volume of unreacted oxygen remaining in the original sample? Answer is 25 centimeter cube. Answer A. Okay. Therefore, the answer for question 27 is A. Question 28. Consider the following Maxwell-Boltzmann distribution curves, which represents the distribution in the value of activation energy at a lower temperature. Okay. You have to see these 4 curves, and you have to tell which represents the value, which represent the distribution and value of activation energy at low temperature. When the temperature is low, we can say the kinetic energy of the particle will be low. Hence, less number of particles will have energy greater than activation energy. So we have to look for a graph which shows lower kinetic energy and lower activation energy. If I see this graph A, the kinetic energy is low, energy greater than activation energy is also low. Only this much particles have energy greater than activation energy. A can be your option, but we'll look for B and C and D also. If I say A, C, A and B, B cannot be an option as compared to A. Why? Because it has lower activation energy and more number of particles have energy greater than activation energy, which is not possible. As my concept says that at lower temperature, the energy, less number of particles will have, less particle will have energy greater than activation energy. Therefore, B cannot be the answer. If I talk about C, this says that the kinetic energy is high. If I compare this A and C, the kinetic energy, or we can say the most probable energy, is higher, which is not possible because temperature is low. Hence, C can also not the answer. If we see option D, the activation energy is very low, and thus this number of particles will have energy greater than activation energy. Hence, even as at low temperature, more number of particles have energy greater than activation energy, which is also again not possible. Out of these 4 probable, these 4 graphs, the most probable graph or most possible graph which can show this distribution and activation energy at low temperature is A. So my answer will be A for question number 28. Next question is question 29, which says consider the following system at equilibrium. Nitrogen reacts with 3 moles of hydrogen, gives you 2 moles of ammonia. The total mole of the reactants are 4 mole and the products is 2 mole. That is, pressure is high towards the reactant side and pressure is low towards product side. Okay. Exothermic reaction. Which row correctly describes the initial effect of change in pressure on the equilibrium position and the relationship between Q and K? This initial effect is an important keyword here. Now, what should I know here is if I increase pressure, reaction move towards less mole side, that is, it will move towards forward direction. If I decrease pressure, reaction move towards more mole side, that is backward direction. These 2 concepts first I will see. Change in pressure, decrease. If I decrease pressure, the reaction will move towards left. Yes, correct. It means option A can be correct. If I increase pressure, the reaction moves to back left hand side. No, wrong. If I decrease pressure, the reaction moves towards right hand side. If I decrease pressure, it should move towards left hand side. It is also wrong. If I increase pressure, the reaction move towards right hand side. If I increase pressure, the reaction move towards right hand side or backward direction, forward direction. It means option D can also be correct. So we have two options which could be correct, A and D. Now for A and D, these two are correct. But now we have to look for Q and K. The Q means reaction coefficient at any given instant of time, and that will be equals to the partial pressure of gas, that is ammonia to the power 2 upon the partial pressure of nitrogen into partial pressure of hydrogen to the power 3. When I see this reaction coefficient and we say pressure decreases, then there will be more decrease of pressure for the reactants since they are more moles. It means the denominator will decrease more. Thus, the value of Q will become greater than K. The value of Q will become greater than K. That is, relationship between Q and K, it will be greater. And since in this Q is less than K, hence this is wrong. And for this Q is less than K. Now we'll come to option D. Option D, we are increasing the pressure. If I am increasing pressure, means there will be increase in pressure for both reactants and products. More increase in terms of reactants and less increase in terms of product. More increase in terms of reactants and less increase in terms of product. Hence, the denominator is increasing more. Therefore, the value of Q will be less than K. In this case, the denominator is increasing more. Hence, the value of Q will be less than K. Thus, option D will be correct. Hence, for question number 29, answer is D. The best answer for this is D, not A. The following results were obtained from the acid catalyzed reaction between iodine and propanol. Okay, there are 4 experiments. Initial concentrations are given and the initial rate is given. If I see experiment number 1 and 3, the concentration of acetone is constant, concentration of iodine half, and concentration of hydrogen ions constant. What has happened to the rate? Constant. No change in the rate. It means if I change the concentration of iodine, there is no change in the rate. Therefore, order with respect to iodine is 0. Okay, order with respect to iodine is 0. Next, we see experiment number 1 and 4. If I see experiment number 1 and 4, concentration of iodine constant and concentration of H plus ions half, and the rate is also halved. From 5.6 it has become 2.8. Concentration halved, rate becomes half. It means it is concentration halved. Concentration of H plus ion is halved and rate has also become half. It means it is first order with respect to H plus ion. Okay. Now, experiment number 2 and 4. The concentration of acetone doubled. The concentration of iodine constant. Concentration of H plus ion constant. And the rate has become from 1.4 to 2.8 double. Concentration doubles. Rate doubles. It means it is again first order with respect to acetone. What my answer? First order with respect to acetone. Okay. 0 order with respect to iodine. Okay. And first order with respect to H plus ions. Okay. It means option 1 should be correct because rest they do not have the same options. This is wrong. And here these are wrong. Here this is wrong. It means option A is the correct answer. Answer is A option. Question 30, answer A. Next question is question 31. It says the acid catalyzed a reaction between iodine and propanol was carried out at various temperatures to find the activation energy. And the graph is plotted and the slope of the graph calculated is minus 6400. We know a graph is plotted between ln kn 1 upon t, and the slope of this graph, which is already calculated and given to us, is minus 6400. What is asking? Is asking which expression gives the activation energy for this reaction, and the formula is given. We know there is a direct formula, slope equals to minus EA upon R. When we have a slope of this graph, we can find out the activation energy directly by the help of this. Next question is question 32, which says that
minus 6400
which two species
equals
can
to
both
minus EA
Bronsted-Lowry acid
upon
and
R.
Bronsted-Lowry bases. We have to
And minus
find out
cancel, I
which
can
two
say
species
EA
can act as
equals
both
to
Bronsted-Lowry acid and base.
6400 into R.
It means
And this comes out to be joule. In order to
species
convert
to
it
act as
into joule, we have to
Bronsted-Lowry
divide it
acid,
by 1000.
it should have a
That
proton.
will gives us in kilojoule.
And for a species to act as Bronsted-Lowry
mole.
base,
What should be my
it should
answer?
accept a proton.
My answer should be
Accept a
6400 into R upon
and it
1000
should
kilojoule per
donate
mole,
a
which should be
proton.
B.
It should have a proton, thus it can donate. Now if I see A, H3PO4 cannot accept a proton, thus it cannot act as both Bronsted-Lowry acid and base. HPO4 2 minus and H2PO4 minus, both species can donate as well as accept a proton, hence the probable answer is B. But if I see other options, see that it can, this HPO4 2 minus can accept as well as donate, but PO4 3 minus cannot donate. And similarly again PO4 3 minus cannot, therefore C and D cannot be the answers. Answer for 32 is B. Question 33, a solution is pH3. What is the hydroxide concentration OH ion of the solution? pH3 means H plus ion concentration equals to 10 to the power minus 3. And for a solution, the sum total of, that is the product of H plus ions into OH ions, is always equals to Kw, and that is equals to 10 to the power minus 14. If my H plus ion is 10 to the power minus 3 into X, that is equals to OH ions, I take an X, therefore OH ion concentration or X will be equals to 10 to the power minus 14 upon 10 to the power minus 3, that is 10 to the power minus 11. OH minus ion concentration is 10 to the power minus 11. Okay, answer is D. 33, answer D. 34, ammonia, NH3 and nitrous acid HNO2 are compounds of nitrogen. What is the oxidation state of nitrogen in these compounds? In NH3, the oxidation state of nitrogen is X plus. Since hydrogen is bonded with a non-metal, therefore its oxidation is plus 1, X plus 1 into 3, and that is equal to 0. Therefore X comes out to be minus 3. So for ammonia it should be minus 3, therefore the answer would be B or C, B and D. Now for HNO2. HNO2, hydrogen plus 1 oxidation state plus X plus oxygen minus 2 into 2, and that is equals to minus 2 into 2, and that should be equals to 0. X comes out to be X equals to plus 3. So for HNO2 the nitrogen is coming out to be plus 3, and for NH3 the oxidation state of nitrogen coming out to be minus 3. Minus 10 plus 3 the answer is D. Minus 3 plus 3, answer is D. Minus 3 for ammonia and plus 3 for HNO2. 34 answer D. Question 35. Below is the reactivity series of selected elements arranged in the highest activity to lowest. Means it is the most reactive and this is the least reactive. Which reaction is spontaneous? It means which reaction can take place. Cd plus 2 ions react with lead. When Cd plus 2 Cd is more reactive than lead, the reaction will not take place. It means A is not possible. Fe2 plus Sn. Fe2 plus is more reactive than tin. Again the reaction cannot take place. Answer B is also wrong. Zn2 plus Cu gives you Cu2 plus Zn. Zn2 plus Cu gives you Cu2 plus Zn. Again copper is less reactive than zinc. Therefore this reaction again cannot take place. Okay. Ni2 plus Co gives you CO2 plus Ni. Ni2 plus CO. CO is more reactive than nickel. Hence the reaction can take place and that will be spontaneous. Answer is D. Question 35, answer is D. Question 36. Which alcohol and conditions would produce highest yield of methyl propanoic acid? We want to prepare methyl propanoic acid. Okay, what is methyl propanoic acid? This is methyl propanoic acid. 2-methyl propanetol. Whenever I want to prepare acid from an alcohol, I have to reflux. My first answer should be reflux. Reflux is answer A or D, either of the two. Now 2-methyl propanetol, 2-methyl propanenol. Only vanols, that is the primary alcohols. Only vanols of the primary alcohol, they can be converted into propanic acid. Hence the answer is B. Therefore the answer for question number 36 is B. Reason is primary alcohols can be reduced to carboxylic acid by refluxing. Answer option is B. Question 37. Which correctly shows heterolytic bond fission. So whenever heterolytic bond fission takes place, always a nucleophile and an electrophile is produced. That is a negatively charged species, and electrophile, which is a positive charged species, is produced. A positive charged species is produced. So when I see heterolytic bond fission, a positive and negative unequal distribution of electron takes place. more electronegative will take the bond pair of electrons. If they are of same electronegativity, since I can see in all the 4 options it is bromine, thus one bromine will become positive, other will become negative. If I see the option A, they are forming on positive and negative ions, but the arrow they are showing is going to both bromine, which is not possible. It is a direction of a homolytic fission, not a heterolytic. It's wrong. Similarly, B shows formation of a free radical, which is again a homolytic fission, not a heterolytic fission. C shows the transfer of electrons taking place to bromine, thus one bromine should form a negative and other should form a positive ion. This option C can be possible, be my answer, but if I look for option B, we can see the Br electrons are transferred to, these electrons are transferred to this bromine and it's forming 2 Br free radical, which is again wrong. Therefore, the correct option is answer 30, question 37, answer C. Next question is question 38, which says what is the role of Cn minus ion in the reaction of 1 chloropropane with excess KCN? So when this reaction takes place, the Cl, which is a nucleophile, are replaced by Cn ions. So we can say the Cn minus ion, they are nucleophiles. Okay, and what they are doing, these nucleophiles, they are donating the electron pair to the carbon and forming a bond. Therefore, they are donates a lone pair, hence they act as Lewis base and a nucleophile. Lewis base and nucleophile, answer is D. A is electrophile and Lewis base, not possible. Nucleophile and Lewis acid, not possible. Electrophile and Lewis base acid, not possible. So it is a nucleophile and a Lewis base. The answer will be 38th question, answer D. Next question is question 39, which says that when an excess of ammonia was added to hydrochloric acid, ammonia is a weak base, hydrochloric acid is a strong acid. So it's a titration between weak base and strong acid. What we are adding? We are adding ammonia to hydrochloric acid. Okay. The following neutralization curves was obtained. Okay. And this neutralization curve is showing starting from around 0 and ending around 8, 9, 10. Around 8, 9, 10. Okay. And the equivalence point we can see is start from about this and goes to this. This is the equivalent point range. The half of this equivalence point, if I mark half of this equivalence point, this will be around this point. This will be half of the equivalence point, which comes to be around here. And this 1, 2, 3, 4, 5, it comes around 5, between 5 and 6. The equivalence point of this graph lies between around 5 and 6. Okay, this is what I can read from this graph. Question is saying which would be the best indicator for this titration. For identifying an indicator for titration, we should know the pH range of the indicator, and that is always equals to pK plus minus 1. And this pH range of indicator should lie in the equivalence point range. Okay. Now I have values of pK. If I add plus minus 1 to 7.9 phenol red, it will be from around 7, that is 6.9, to around 8.9, which is not in my equivalence point range. Hence, this is wrong. Bromothiamol blue plus minus 1 is around 6 to around 8, which is outside the equivalence point range. It's also wrong. Phenolphthalein is also wrong because outside the my equivalence point range. Bromocresol green lies within the equivalence point range. Hence, out of these 3 indicators, bromocresol green will be my best indicator for this titration. That is, answer for question number 39 is D. Bromocresol green. Question 40. Which species would take part in substitution reaction with benzene? We know benzene undergoes, whenever we talk about benzene and aromatic compounds, they undergoes electrophilic substitution reactions. It should be an electrophile, and electrophile are species having a positive charge. Chlorine cannot be a species which take part. Cl free radical cannot. Cl minus cannot because of nucleophile. Hence the answer is Cl plus, which is a electrophile. Thus Cl plus ion would take part in substitution reaction with benzene. This is question number 40. Answer C. That's all about this paper of May 2025, and I hope this will be useful for you. Thank you very much for watching. And one more thing, for more detailed help in IB and IGCSE examination, you can visit to this website www.ibvijain.com, and this website has many useful features for IB and IGCSE, like we have test papers, we have topic-wise question banks, we have topic-wise practice papers, and a comprehensive course which contains all complete study material which is required for the IB preparation. and that contains the practice papers, the test papers, the question banks, the subjective question banks, the question bank for paper 1B. And one unique feature of this is, if you attempt these papers and practice papers, the MCQ will be automatically checked and the answers will be received as soon as you submit the papers. Whereas the subjective question banks or question papers, if you write and upload on the website, then these will be checked by the experts and the result will be sent to you within 48 hours. And I hope this will be helpful for your preparations. I recommend you to please go and visit this website, and if you think it is useful, you can buy it and purchase it. Thank you very much once again. Thank you.